Hello friends, welcome back to this online lecture series on earthquake resistant design of structures. In the previous lecture, we have seen a couple of theories regarding the origin of earthquake or the causes of earthquake. In this particular lecture, we are going to focus on some basic terminologies that are going to be useful for earthquake engineering and that we hear in day-to-day life. For example, we are going to talk about hypocenter, epicenter, focal depth, aftershock, before shock, and at the same time we are also going to discuss regarding intensity and magnitude, right? So let us start the discussion. Right, so first we look at the basic terminologies that we refer in our day-to-day life, that is epicenter and focal depth, aftershocks and before shock. Now I have tried to explain this particular scenario by means of one small figure that is shown on your screen here, right? So we talk about the focus or the hypocenter, then the point on the fault where the slip starts, that particular point is known as the focus, right? So what you can say is that we have seen in the last lecture the types of different fault, that is normal fault, reverse fault and the strike slip fault. Now depending on any type of fault, what is going to happen is that when the fault is going to take place, then as a result of that the energy release is going to take place, and when energy release is going to take place, then it is going to transform into heat energy and later on the creation of seismic wave is going to be there, right? So when this particular thing will happen, then what is going to happen is that the epicenter is going to be located at the top portion of the surface of the earth, whereas the focus may be, or the focus or the initiation point may be located well below the surface of the earth, right? So that is why the definition of focus is that the point on the fault where the slip starts, that is the point from where the stress will enhance to such a level that the plates are, that the adjacent plates will no longer be able to sustain, and from where the movement will likely to be initiated. So that particular point is known as the focus. Now if you look at the figure carefully, then the perpendicular vertical distance just above the focus on the surface of the earth, the point that we will achieve at that particular point, that point is known as our epicenter. Now this point, I think it is known to everyone, right? Everyone in day-to-day life we hear this particular thing. Whenever an earthquake occurs, we hear that epicenter is so and so place, right? So this is the technical definition or technical meaning of epicenter that we are discussing here today. That is the vertical distance or the perpendicular distance just above the focus on the surface of the earth is known as epicenter. Then the second question comes is focal depth. Based on the focal depth, you will be able to classify the earthquake whether it is a minor earthquake, moderate earthquake, strong or a major earthquake, right? So as a result of that, focal depth is an important definition. So the distance between the focus and the epicenter is known as focal depth, right? The third definition is epicentral distance. Now for example, as you can see in the figure, I have shown one small blue color block over here, which is, you can consider it as a building or a bungalow, right? So if I want to know the distance of this particular building from the epicenter, then the distance between the epicenter and this particular building will be known as epicentral distance. Lastly, and two more definitions, but very important definitions. Why? Because in day-to-day life we hear both these things. First is the foreshocks and second is the aftershocks, right? So whenever major earthquake occurs, then either it is prior to that earthquake you will be experiencing the foreshocks, or once the major earthquake has taken place, then afterwards you will be experiencing the aftershocks. So if the minor tremors are felt before a major earthquake, then that particular type of earthquake is known as foreshocks, and if minor tremors are felt after a major earthquake has taken place, then that particular thing is known as aftershocks, right? So these are basic terminologies that we hear related to earthquake engineering in day-to-day life, and I think in layman language also these definitions can be clearly understood and it is necessary for everybody's knowledge, right? Now the next important thing is regarding magnitude. In case of magnitude also, we have heard several times whenever an earthquake takes place, we all hear that an earthquake of so and so magnitude has occurred. For example, let us say an earthquake of 7 magnitude has occurred, earthquake of 5 magnitude has occurred, right? But what is actually magnitude, that also we need to understand, and that is what we are going to discuss here today, right? So magnitude is basically a quantitative measure of the actual size of the earthquake, right? So when I am saying quantitative, that means it is going to give me the quantity. Now quantity in terms of what? It is going to give me the quantity of the energy that is released during particular earthquake that is going to take place, right? So if I want to redefine magnitude, then I can say that it is basically a measure of the release of energy at the time of the initiation of the earthquake, right? Now there is one very well known personality that is associated with the magnitude, and that is Professor Charles Richter. Why? Because whenever the earthquake is there, we everywhere see that an earthquake of magnitude 7 on Richter scale, an earthquake of magnitude 5 on Richter scale. So this Richter scale is having the name of Professor Charles Richter, and he was the one who coined the term the as Richter scale. Now, why he was interested in this particular thing, or what led to this particular definition of Richter scale? Then he had two reasons for that thing. First reason was that he observed that at the same distance, seismograms. Now, seismograms, everyone note that the instrument that is used to record the earthquake is known as seismograms. You have seismograms and you have seismographs. Both are different, right? But the one that is used to record the earthquake, that is known as seismographs. So he said that at the same distance, the seismograms of larger earthquake had bigger wave amplitudes as compared to that of the smaller earthquake. That is, when large amount of energy is going to release, then as a result of that, what is going to happen is that the wave amplitude is going to have a larger amplitude. And if the less amount of energy is released, then the shape of the amplitude or the height of the amplitude is going to be on the lesser side. And second observation was that for a given earthquake, seismographs that are placed at farther distance had smaller wave amplitudes than those at closer distance. That is what he was saying, that for a given earthquake, let us say that if the earthquake of 5 magnitude has taken place, and if one seismograph is placed near to this particular object that I am standing over here, and other one is placed far above, then the record on the seismogram showed that the one that was placed closer had higher amplitude as compared to the one that was placed far away. So as a result of these two reasons, he proposed one term, or he prepared one scale which was known as the magnitude scale, and it became famous as the Richter scale. Now this Richter scale is having the range in terms of numerical values starting from 1 and as high as 8, right? So as you can see in the bottom side of your screen, the tabular form is given where the classification of earthquake is done based on the magnitude, right? So if the earthquake is less than 3 on the magnitude, then it can be considered as a very minor earthquake, and if the having a magnitude greater than 8, then it can be considered as a major earthquake or a great earthquake, right? And in the third column, the average assumption is also given, that what is the possibility of these earthquakes to occur annually, right? So you can see that there are very high chances of minor earthquakes or very minor earthquakes or light earthquakes that are going to occur. But if you talk about major earthquake or great earthquake, then it is said that only one major earthquake is expected to occur once in a year all around the world, right? Now what happens is that we have seen that we have understood the numbers, that it is 3, 4, 5, 6, 7 and 8, right? But does it make any sense that if there is a change in the value from 5 to 6, is it going to have that much greater impact or not? That is also to be understood, right? So it is going to have a very big impact. Why? Because an increase in magnitude by 1 implies that 10 times higher wave amplitude is going to be there, or 31 times more energy is going to be released, right? So imagine an earthquake of magnitude 3 and imagine an earthquake of magnitude 6. So what is going to happen is that the amount of energy that is going to be released in case of the earthquake of magnitude 6 is going to be 93 times higher as compared to that of the other one, right? So most of this energy that is released is in the form of heat energy, that I already told you, and this heat energy will result in the fracturing of rocks. And after these rocks are fractured, then what is going to happen is only a little amount of energy will be there in the formation of seismic waves, and these seismic waves will be either reflected or refracted on the surface of the earth, and then it will raise the particular building where the displacement or shaking is likely to take place. Right. Now next, here you can see a comparison that depending on the magnitude of the earthquake, that is starting from 2 and going up to 10, what is the possibility of occurrence of these earthquakes, or what are the chances of these earthquakes occurring in daily life? So if you look at the figure closely, then an earthquake of magnitude 2, it is observed that 10 lakh such earthquakes are observed daily, right? There is a particularly everywhere we have a center here, that is the seismological research center, where the instruments are placed and where the recording of the earthquake. So even the minutest of earthquake is recorded on the surface of the earth. So that is why you can say that, you can see over here in the figure, that it is showing for a magnitude of earthquake in the range of 2 and 3, 10 lakh earthquakes are observed on a daily basis. That is on a year, 10 lakh earthquakes are observed on a yearly basis. But if you go towards the higher side, that is earthquake in the range of 6, 7, 8 in the magnitude, then the amount of earthquake or the number of earthquake on an annual basis is greatly reducing. That is, it is in the range of 1 to 5. That is, an earthquake of magnitude higher than 8 can be expected only once in a year. And at the same time, the other column that is shown over here is also giving you an idea about the amount of energy that is released. Why? Because I told you that in case of magnitude, the importance is about the amount of energy that is released at the initiation of the earthquake. So for an earthquake of magnitude 2, the energy that is released is 56 kg only when you convert in terms of an explosive. But when you talk about an earthquake of 10 magnitude, then you can see that the amount of energy is 56 trillion kg. Right? So you can just see the difference that for a magnitude of 2, the amount of energy is 56 kg, and for a magnitude of 10, the amount of energy is 56 trillion kg. So just see how fast the numbers or the amount of energy is multiplying when the magnitude of the earthquake is going to increase. And lastly, the effect of magnitude is also indicated. That for example, if the earthquake is in the range of 1 to 3, then in that case what is going to happen is that the general perception of the public or the animals is going to be such that they are not going to feel this earthquake. But since seismograms are installed everywhere, the record of this earthquake is possible. When you talk about earthquake in the range of 4 to 5 magnitude, again, minor tremors will be felt, but no damage will be there. And once the earthquake exceeds a magnitude of 6, then the problem starts. Then what is going to happen is that, as you can see in the figure, that strong building is going to be affected, major structural damage is likely to be possible, structural and non-structural damage is likely to be possible, and lastly, the structure is likely to be irreparable in nature. So as and how the scale of the magnitude is going to increase, the effect on the building and the surrounding is also going to increase. Right? So that is all about magnitude. And lastly, we talk about intensity. We already talked about magnitude, but there is a another interesting term which is known as intensity. This intensity term is not highlighted in the news, or it is not known to the common man. But from an engineer's point of view, it is a very important term for us. Why? Because intensity is the qualitative measure of the actual shaking at the location during an earthquake, and it is assigned as Roman capital numerals. In case of magnitude, it was in numerical values, right? That is 1 to 8. Whereas in case of intensity, it is going to be in Roman capitals. And what is it? It is a qualitative measure. So what is going to happen is that the actual shaking that you are going to observe during the type of earthquake, based on that experience of yours, the intensity scale is going to be there. Now there are several intensity scales, however, only two are familiar or two are well famous. The first one is modified Marcelli scale, and second is the MSK scale. Both these scales are very similar in nature and are ranging from a value of 1 to 12, where 1 is the least perspective and 12 is the most severe scale. That is, highest amount of damage is likely to be experienced when intensity scale is showing a value of 12. Now these intensity scales have been prepared based on certain parameters. Then what are those parameters? Then there are three parameters. First is the perception of people and animals during the time of earthquake. That is, how the people are feeling the intensity of shaking when the earthquake is taking place. What is the behavior of the animals? That is also an important parameter. Then the second parameter is the performance of the buildings, whether the buildings are able to stand, whether structural damage is observed, whether non-structural damage is observed. And third is the change in the natural surrounding, that is related to the movement of the plate boundaries. That is, whether a valley is created, mountains are created, or some other type volcanic eruption activity take place, any of these activities are observed. So based on these three parameters, the intensity scale is prepared. Right? So when you talk about the intensity, the distribution of intensity at different places during an earthquake is shown graphically, and it is going to be different at different places. Now, for example, if you draw a graph where you connect all the points on the surface of the earth where equal intensity of earthquake is observed or experienced, then that particular line that is connecting all these dots will be known as isoseismal lines. Right? Similarly, you have mesoseismal lines also. So intensity is basically an indicator of the shaking that you experience during a particular location, right? And during the same earthquake, the possibility is that the magnitude is going to remain same, which is a very important point to be understood. Magnitude does not change depending upon the location, but intensity changes depending on the location of the site with respect to the epicenter, right? If the epicentral distance is far away, then it is going to experience lesser damage as compared to the one that is near. But however, the magnitude is going to remain same. That is an important thing to be understood. Magnitude will not change, but intensity will change. So the focus should be on the intensity and not on the magnitude. But it is difficult for layman to understand this particular thing. Now, how this is going to affect that? So for that, one example is given that if I am lighting in a dark room, if I am lighting a 100-volt bulb, then what is going to happen is that, and if I am trying to read by using that particular lightning, by using the light of that particular 100-watt bulb, then what is going to happen is that if I place my book near to the bulb, or if I sit near to the bulb, then as a result of that I will be able to read clearly. But if I move little bit away, as shown in the figure, then the light is going to be less. So as a result of that, I will be not be able to read it completely, or it will not be clearly visible to me. And if I move totally away, as seen over here, that if it is going at the very far from the bulb, then as a result of that, the light is not going to reach there. So as a result of that, what is going to happen is that the effect of that 100-watt bulb is not going to be there. So what the conclusion, or how we can relate this particular example to magnitude and intensity? Then we can say that magnitude is 100-watt, that is fixed, right? So it is choice is yours whether you are sitting near the bulb or whether you are sitting far away from the bulb, or you are sitting in a normal position. If you will sit near the bulb, then you will experience more light. If you will sit away from the bulb, then you will experience less light. So same thing is with intensity also, that if your building is located near to the epicenter, then even if the magnitude of the earthquake is only 3, where it is said as a very minor earthquake, then also you will experience good amount of damage in the building and you will experience a good amount of shaking. But if the intense magnitude of the earthquake is 6 and your building is located far away from the epicenter, then as a result of that, the damage and the shaking experience will be less. For example, we take the example of Bhuj earthquake, right? So in case of Bhuj earthquake, what happened is that the villages that were located in the surrounding of Bhuj and close to the epicenter experienced a very huge amount of damage. But if we travel from Bhuj to Ahmedabad, then in case of Ahmedabad, we experienced that all the buildings did not devastate. So amount of damage that occurred in case of Ahmedabad was clearly less as compared to that of Bhuj. Why? Because magnitude has remained same, but the intensity has changed. Why the intensity has changed? Because the epicentral distance has increased. And lastly, one tabular form is given that what is the definition of intensity scale according to Marsali. There the classification is given in the range of 1 to 12, where in case of 1 no effect is observed, and in case of 12 it is going to be more severe. So buildings properties and public property is also likely to be damaged, and its comparison with the magnitude scale is also given over here. So that's it for this particular section, where we have discussed regarding the basic terminologies, that is epicenter, focus, focal depth, aftershocks and before shocks, and at the same time we have discussed regarding intensity and magnitude. Lastly, before we end the lecture, we come to the last part, which is known as the difference between magnitude and intensity, which is very important to understand, right? Because everywhere the term magnitude is very much familiar, but again I am repeating, in terms of earthquake engineering, magnitude is not important, intensity is important, right? So what is the difference between magnitude and intensity? This question is very frequently asked everywhere in exam also, right? So difference between magnitude and intensity. So intensity is basically going to measure the shaking in a particular certain locations, whereas in case of magnitude is going to give you an idea regarding the amount of energy that is going to get released, right? So in case of intensity, we can say that earthquakes that are shallow and near the urban areas are going to be greatly felt, and if they are going to be weak in nature, whereas in case of magnitude, the magnitude is going to remain same throughout, and only the change in the energy is going to take place, right? So intensity is very much critical as compared to magnitude. Intensity is going to give you an idea about the actual shaking that is going to take place, and will depend on the epicentral distance, whereas in case of magnitude, epicentral distance will not play a role, and in that case only the amount of energy that is going to be released is going to be important. That's it from my side. Stay tuned for the remaining lectures. Thank you.